Diffusion, yeah.
Recording in
It's
progress.
like from a high concentration to a low concentration.
Diffusion is the movement of particles from the
From
area
a
of the, yeah.
high concentration to a area of a low concentration.
Can you give me any example in our
Like
body? In our body.
uh, what's it called? You said like
hmm
when we
Breathing,
like
breathing.
when yeah, breathing.
Yeah, we breathe in
Also,
oxygen, yes,
yeah,
and we
uh,
exhale carbon dioxide. You know why we
yes,
exhale
carbon.
carbon dioxide? There is also
Mm,
diffusion process because inside our lungs, carbon dioxide concentration, it should be less. Okay, so it should be less. So whenever there is more carbon dioxide in our lungs, so we exhale that out. Okay. Similarly, we inhale oxygen. Why we inhale oxygen? Because the concentration of oxygen is low in our lungs, and in the air, the concentration of oxygen is more. That's why we inhale oxygen in and we exhale carbon dioxide out. Okay. We inhale oxygen in. Why? Because inside our lungs, its concentration is low. And we exhale carbon dioxide out. Why? Because if you compare the carbon dioxide concentration in your lungs and outside in the air, so the concentration of carbon dioxide, whenever it is more in the lungs, so definitely at that moment you exhale carbon dioxide out. So it happens all the day and all the night. We exhale carbon dioxide out and we inhale oxygen in. Clear? And this happens through
yes.
the process of diffusion. Also, one more thing, do we need energy for this process, for the diffusion process?
Uh, yes.
We really need energy. Think about it.
No, no.
It's a natural process. When I was
Yes,
writing the
yes.
definition, I told you what is the definition? Did you note down the
Uh,
definition yesterday?
yeah, yes.
What's
Like
that?
you told me, it's like it was the natural movement of particles
Yeah, it is the
from
passive movement. Okay, it is the passive movement. And what is passive movement?
uh, like
Passive movement
naturally.
means no need of energy. Naturally, it is happening naturally. No need of
Yeah.
energy. Okay. Think about remember these two terminologies: passive movement and active movement. Okay. There will be active movement terminology in the upcoming chapters. Active movement means there is need of energy. Okay. There
Hmm.
is there is need of energy. Okay. In active movement. Whenever there is active movement. So in diffusion there is passive movement. Clear?
Hmm.
Passive movement means it happens naturally. It happens naturally
Natural.
and there is no need of energy. And what can be any other example in our daily life of the diffusion process?
Like you told me, like perfume.
Yeah, perfume spray or any other room freshener. Whenever you spray that in one corner of the room, it's spread out in the whole room after 2 or 3 minutes. Why is this so? Because the area where you spray it, over there in the start there is more concentration of the particles, and after some time, all the particles will be uniform in that room. Okay, so that's why there will be fragrance in the room.
Hmm.
This is the process of diffusion. And whenever a tire punctures and the tire of the car punctures, what happens there? There is also diffusion because inside that tire there is more concentration of the particles, right? So whenever it's punctured, all the particles they diffuse from the tire. That is also an
Mm.
example of diffusion. Okay,
Yeah.
now they have compared the rate. How they have compared? Firstly, over here they have taken cotton wool soaked in ammonia. In this was soaked with ammonia solution because they wanted to check the rate of ammonia gas. Okay, they wanted to check the ammonia gas. What is
Yeah.
the rate of the diffusion of the ammonia gas? And on this side, the cotton wool was soaked in HCl, hydrochloric acid. Okay, and there is this one is a glass tube, and it is sealed from the both ends. Okay. Now they
Mm-hmm.
have mentioned in the first over here the A1, this A is ammonia solution. The cotton wool is soaked with the ammonia solution. At the same time, the cotton wool soaked in hydrochloric acid is put on the this side, on the right side of the tube, right? It gives off valid hydrogen chloride gas. So which gas it will give? It will give hydrogen chloride. The gases
Oh,
diffuse along the tube. White smoke forms when they meet. Okay, over here they have mentioned the smoke will form. Why smoke will form? Because from this side the ammonia is releasing, over from this side the hydrochloric acid is releasing. So they will combine and white smoke will form here. Okay, and the white form now if you see, can you tell me this white smoke, is this near to the ammonia solution or to the hydrochloric acid solution? This
oh,
white smoke,
yeah. It
where
will
it is
be
more? It is more closer to
like
HCl solution or more closer to the ammonia solution?
it's it's
Hmm. You know,
it's yeah.
like this from here till this. This is the whole tube, and this maybe this is the center, right? Maybe this one will be the center. Now
Yeah.
think about it. Where white smoke is formed? Closer to the
It's yeah.
hydrochloric acid? Yeah, it is closer to the hydrochloric
It's
acid.
yeah.
So it
Yeah.
means the white smoke formed closer to the B, so the ammonia particles have traveled further than the hydrogen. What does it mean? That to form the smoke over this position, the ammonia they traveled a, a more distance as compared to the HCl, right?
Yeah.
The ammonia solution it traveled more as compared to
Mm-hmm.
the hydrogen chloride particles, which mean that they have traveled faster. Which have traveled faster? Ammonia have traveled faster. Let me explain this again. They are telling us that you have two gases, okay, and they both are cotton soaked. Then after some time, there was white smoke formed. Now in this tube, white smoke is formed closer to this hydrochloric acid. It means the hydrochloric gas just covered this distance, okay? It just covered this distance to form the smoke. Actually, this smoke is a mixture of ammonia and HCl. So hydrochloric acid just traveled this distance, while the ammonia traveled this distance. Okay, this much distance. So now, can you tell me which gas traveled more distance, ammonia or HCl? You have
Uh,
maybe you have checked it
ammonia.
after 5 minutes. Okay, yeah. So ammonia have traveled more distance. So what does we conclude from here? That ammonia travel at a faster rate. That's why it covered more distance. Like if you have two cars and both cars, you there is a race of the 100 kilometers, and one car reaches before the other. Like car A, it reaches 5 minutes before the other one. What you will say? That the speed of the car A was more than that of the car B, right?
Mhm.
So this is what
Yeah.
we say the ammonia. Its speed is more. It travel at a faster rate as compared to the hydrochloric acid. So this is what we are discussing here, the rate of diffusion. That some of the gases they diffuse in a shorter period of time, but some other gases they take more time. Okay,
Yeah.
and the reason behind this is if you see, ammonia is the molar mass of the ammonia. What is the molar mass of ammonia? You have periodic
I
table right now.
not right now, but I think I know ammonia at least. I think so.
What's that for ammonia?
Is it like what's it called? For
It is
wait no,
mhm,
around 14 or
14 plus 3. 14 is for nitrogen,
14.
plus
Yeah.
3 is for hydrogen. Yeah, so it is
Okay.
17. The molar mass of ammonia is 17. And what about HCl?
HCl hydrogen is
1 plus chlorine
one
is
and chlorine
35.5,
is
right?
yeah, there's
So in total it is 36.5. If you see,
yeah, there's
this is 17 gram per mole ammonia and HCl is 36.5 gram per mole. So which one is heavy? HCl or ammonia? Which one is heavy?
what's it called? HCl.
Yes, that's why HCl will take more time to travel
Mhm.
because it is heavy. You know heavy things they take time. While when
Yeah.
if you compare two person like one is person A is thin and the person B is uh, a fatty person and they both joined a race. So obviously the person who is the thinner one he will complete the race before the other
Wait.
one. Why? Because
Yeah.
that person is lighter in weight. Okay.
Mhm.
So whenever you have lighter things or the gas which have less mass, that gas will travel at a faster rate. Okay, that gas will travel at a
Mhm.
faster rate. That's why ammonia will travel at faster rate, and that's why ammonia has covered more distance as compared to the HCl. Okay,
Yeah.
clear?
Yes.
Now they have mentioned. Imagine the marble on the right is the heavier one. On the right is which one is right? This orange. This is heavy. Which marble will bounce further and faster when they collide? If they will collide with each other, like they are colliding with each other, now think about it and tell me which ball, the red ball or the blue ball, which will bounce further and at a faster rate.
The blue one,
Yeah, why?
because it's a bit small.
Yeah, it is bit small and it is less heavy. It is lighter in weight. It
Yeah.
is lighter in
Yes.
weight. So it will bounce at a further and at a faster rate. Okay, maybe it will came at this position. So this is the concept we are using here, which applies here. So we say that the lower the mass of its particle, the faster a gas will diffuse. Clear? Are you clear with this?
Yes.
Okay. This makes sense when you think about it. When particles collide and bounce away, the lighter particle will bounce further and faster. Do you agree with this?
Mhm.
That the lighter particles will
Uh,
bounce further and faster.
yeah. Yes.
Yes. Because they are lighter in weight, that's why they will bounce at a
Will
farther
further.
apart.
Yes.
Yes. The particles in the two gases above are molecules. Okay, these are molecules. The mass of the molecule is called relative molecular mass. I told you this one that whenever you have two similar things, okay, you can relate them, and you can how you can relate them by their mass. So if you relate them, these two,
Mhm.
you will say that this one is smaller ball and this one is heavy one. This is heavy. This is lighter. This is larger in size and this ball is smaller in size. And this one is lighter and this one is
Mhm.
heavy. So similarly, we compare this
Mhm.
ammonia and HCl. We say that ammonia is a lighter gas. Okay, it is a lighter gas.
Lighter.
Yes, and the HCl is heavier gas. Okay,
Yeah.
so this is known as relative masses. You are comparing the masses. You are relating. So whenever we relate two masses, we say the lower the relative molecular mass of something, the faster the gas will diffuse. If you relate these two,
Mhm.
which one have low mass? Ammonia or HCl? Low mass.
It's low mass ammonia.
Yeah, ammonia has a lower mass. So the relative molecular mass of ammonia is less as compared to the relative molecular mass of the hydrochloric acid, right?
Yeah.
So that's why we say the lower the relative molecular mass, the faster a gas will diffuse. Clear?
Mhm. Yes.
Note that everything in the experiment above needs to be at the same temperature, room temperature, for a valid test. But they're saying that everything need to be at same temperature because whenever you are comparing whenever you are doing an experiment, you cannot fluctuate the things during the experiment.
Yeah.
You
You have
set
to
the
keep it
conditions,
same.
like for example, if you want to do this experiment in daylight. Okay, so you will fix
Yeah.
this experiment conditions that it will happen in
Indeed.
daylight. You will mention the temperature. That temperature for this should be 35 degrees Celsius or 25 degrees Celsius, and it should
The
be
time,
hmm,
how long it will take.
yeah, and the time. If you want to check this for 15 minutes, okay,
Yeah.
and then also what you can see, the container is closed. Okay, this glass tube is
Mhm.
closed. So these
Yeah.
all things, you keep these all things in mind while performing the experiment, any type of experiment in physics, in biology, in chemistry. You set the conditions first, okay? Firstly, you have, the
Yeah.
precautionary measures. We have precautionary measures and we have What are precautionary measures? Precautionary measures are those things which are just like instructions that for this experiment you need to follow these protocols. Like for example, you know HCl is harmful. You cannot, if you inhale HCl, it can cause some serious problems in your body. It can cause some serious breathing issues. That is why whenever you are performing an experiment in which HCl is used, you wear proper clothing and you wear mask and all the things. You have the glasses which we use in the labs. So these are known as precautionary measures. We do the precautionary measures. Okay, let me write it over here. As well as before any experiment, we set the conditions. Okay, precautionary measures are what you need to do before doing this experiment. These are known as precautionary measures. That you need to wear proper dress. You have a mask, you have gloves, you have glasses, and you must know which substance can do whatever. Like what are the some of the negative impacts of this thing, like the HCl or ammonia. You must know about these things before doing any experiment. Okay. Otherwise, obviously, you will have some of the major issues while performing
Mhm.
the experiment. And the second thing is the conditions. Okay, so that's why
Yeah.
they have mentioned about the condition over here. That note that you will do this on room temperature, and usually we take 25 degrees Celsius at the as the room temperature. Okay, whenever there is
Mhm.
discussion of the room temperature usually is 25 degrees Celsius.
Yeah.
Okay. That is because, as you know, the temperature also affect the how fast gas particles will move. Why they have mentioned that if you are performing an experiment, you need to keep you need to keep the temperature constant. Why is it so? Because otherwise, if you fluctuate the temperature, the diffusion rate will change. Then you cannot
Yeah.
easily, then you know what will happen then it will be difficult for you to analyze that which gas moves faster rate and which gas moves at a lower rate,
Mhm.
okay, at a slow rate. So that's why you
Yeah.
keep it at room temperature should be constant, okay. Otherwise if the
Mhm.
temperature is changing, then the diffusion will change. And I told you some of the factors on which diffusion is dependent. Can you tell me? It is dependent on temperature as well as,
Uh, like gas particles.
yeah, mm, not the gas particles. There will be diffusion. I am saying like diffusion rate. Diffusion rate will be affected by the temperature. Like if you increase the temperature, diffusion will increase.
Maybe
M-
maybe like the day, like is it a night or
molecular masses. That is about the molecular masses. Okay.
yeah.
If you have lighter gas, the diffusion will be more, and if you have a heavy gas, the diffusion rate will be less.
Yes.
Clear?
Yeah.
Now you see this. The particles that carry scent spread by diffusion. Okay, they spread by no need for help from you. Like this one, if you see the fragrance of the of this will spread out in the room or wherever you place it. Okay, now we will do the exercise. This one. These are checkup on the chapter one. We will do these, and I will take your test on in the next week. Okay, for this chapter. Now, what you need to do is take your notebook and a pencil, and whatever we are discussing, you can just write the answer 1A or 1B. Then after the class, you can review your answers. Clear? I will take your test on Monday. Okay, on Monday, inshallah, for the chapter one. There will be questions for P1 and P2 as well, both. Okay, P1 there will be MCQs, right? And in P2 there will be short questions as well as long questions. So today we will prepare these all and how I will ask you. Okay, first thing is give the correct name for each change of state. Okay, what is the name for A? This one,
Or
solid to liquid.
solid to liquid, it would be what's it called?
Hmm.
Melting.
Yes. What is liquid to solid?
Liquid to solid is what's it called? Uh,
Think about it.
like freezing.
Yeah, freezing. And what's the other name of freezing?
I was thinking about that. I forgot also.
Solidification. It is solidification. Okay.
Solidification. Yeah.
Yeah, it is solidification. What about gas to liquid?
Gas to liquid, it would be uh, evapor
Hmm.
evaporation.
Gas to liquid. Gas to liquid. Think about it. It is reverse process. Gas to liquid.
I remember it was like
You're right.
condensation.
Yeah, this is condensation reaction.
Yeah,
Okay.
like condensation. Yeah,
What about the D?
and liquid to gas is evaporation.
Yeah, liquid to gas, that is boiling. Actually, this is boiling.
The boiling point,
And
but
then
evaporation.
yeah, you can write evaporation as well in the bracket. Okay, because the main
Okay.
point is evaporation, the boiling. The boiling happens and evaporation
Yeah.
is the we have melting and boiling, freezing and condensation. Okay, next. A large crystal of potassium manganate was split. Potassium manganate is this KMnO4. You can write it on your book. Was placed in the bottom of a beaker. This potassium manganate. It was placed in the bottom of the beaker of a cold water and left for several hours. They have mentioned that they have taken the crystal of the potassium manganate and placed it in the cold water. Describe what would be seen after 5 minutes. What can happen in this?
Uh, like
Hmm?
maybe what's it called? The cold water could change. Temperature could change.
Okay, this is a new question. You can think about it like that there is.
Yeah.
Okay, over here they have mentioned. Explain why this show that particle exists, the movement of dust specks in air, the purple color spreading when a crystal of potassium, the purple color spreading when a crystal of potassium manganate is placed in water. You know the potassium manganate is purple in color. Okay, it is purple in color. So when you place it in cold water, after some time, what will happen? The solution will become purple. Okay,
Mhm.
so after few minutes, what will happen? There will be
The solution compare.
initially after they have mentioned actually they have asked about after 5 minutes and after several hours. So in after 5 minutes you will say the purple over here. Let me change the color. It looks like I am mistaking about the. Is this purple? Yeah, this is purple. So after 5 minutes, what will happen? Deep purple color will appear. Deep
Yeah.
purple color
Purple
will
color
appear
will appear.
near this crystal. Okay, deep purple color will appear near this crystal. Okay. Then after
Yes.
several hours, what will happen? Now think about it. What
What's
will
it
happen
called?
after several hours? Initially, there was deep purple color over here, right? At this position.
Yeah.
After several hours, what will happen? Entire
The
solution will
purple
become,
color will change.
yeah, entire solution will become purple. Okay?
Purple. Yeah.
Yeah, there will be uniform purple color. Now, explain your answer using the idea of the particles. Now you have to explain it. In this, you just told that what will be the color. Now you have to explain why is it so? Why there is deep color over here, deep purple color after 5 minutes, and why after some time the whole the solution, all of the solution become purple? Why is this so? Can you tell me which process is this? We have discussed. But
Uh, like
uh
from like
what is
crystal. No.
what we say that whenever there are particles in the area, they are, where there are more, and they move from the area of higher concentration toward the area of low concentration. What is it?
Diffusion.
Yeah. So this is
Diffusion.
diffusion. Now you have to explain according to diffusion. Can you explain according to diffusion what is happening after 5 minutes and what is happening after several hours?
Maybe after like 5 minutes,
Mm-hmm.
the concentration is still high, but after several hours, the concentration goes from from uh,
Mm-hmm.
what's it called? From high area to from high
Towards
to
the
low
from
concentration.
the
So it
area of
spreads.
higher concentration. You will say
Yeah.
initially after 5 minutes this crystal started dissolving in the water. Okay, this crystal of the potassium manganate it started dissolving in the water, and there are more particles near the crystal. Okay, over here in this region, at the bottom, you will see at the bottom of the beaker, there are more particles of the potassium manganate. So there is more concentration of the potassium manganate near the bottom of the beaker. But after several hours, due to the diffusion process, the particles will move and they will spread out. They will spread out, and after several hours, the entire solution will become purple. Clear? Are
No,
you clear with the answer or should I repeat it?
no, I'm clear.
No. Now can you explain this? What is the idea?
Okay.
Hmm.
So, what's it called?
Firstly, you will tell
Like,
after 5 minutes, then explain after several hours.
yeah, after 5 minutes, like when the crystal like starts to dissolve a bit, that's why it becomes a little bit purple. But after several hours, like from high concentration area to low concentration area, it will diffuse like a lot, and then the purple will spread around the water.
Yes, because of the diffusion process. Okay, because of the diffusion process. Okay, then name the two processes that took place during this experiment. What are the two processes?
Uh, Name to diffusion
And
and what's it called?
think
I
about it.
just
Hmm.
no, like I just said like. When the color goes from purple to crystallization.
There is no, is there a crystal formation?
No, no, there is no crystal form.
Hmm.
Crystal is dissolving.
Yeah, there is dissolution. Okay, you will say
Yeah.
dissolution.
Just- yeah.
Dissolution. And the first one is diffusion. The process is diffusion. Clear?
Yeah. Yes.
Okay. Are you clear with this question? This is easy, right?
Yes. Yeah.
Maybe in your exercise there will be some different questions. So you must solve that exercise. Okay, I will take your test after in the next week. Firstly, we will do the past papers, so you will have idea. On Monday, we will do past papers of this chapter for the paper one and
Hmm.
paper two. Then I will take your test on Tuesday, right? Okay.
Hmm.
But you have time
Okay.
now. You can prepare on the weekend. You can prepare this chapter. Okay.
Okay.
Just prepare the theory of this chapter, which we have done in the class, and solve the exercise. And if you have past papers, try to solve them. Otherwise, we will solve some of the past papers in the upcoming class.
Hmm.
Okay. Use the idea of the particles to explain why solids have a definite shape. Yeah. According to the particles, idea of the particles. This we have done in the first chapter, in the first lecture.
Uh,
Why solids have a definite shape?
what's it called? Because they're in a lattice shape because like
Lattice,
particles are
lattice.
close to each
They have a
because
definite shape.
uh
Why they have? They are asking why they have a definite shape. So you will mention the particles are closely placed to each other,
closely,
right? Yeah.
they're close to each
The particles are closely packed or closely placed. There will be no spaces. Okay, there will
other.
be no spaces. The particles
Yeah.
are
Yes.
closely placed to each other, and they form a regular pattern. A regular pattern. Okay, they form a
Yes.
regular,
Regular path.
and you can write in bracket the lattice. Okay, I told you the lattice.
Hmm.
The regular pattern
Yes.
for solid is known as lattice.
Yeah.
LATTICE. Okay. Liquid fill the bottom of the container. Now what's that?
Liquid fill the bottom of the container.
Hmm.
Uh, so like what does this mean? Like liquid fill the bottom of a container?
Hmm. What does it mean?
Like a
Like
lot
they
of
are
liquid.
asking, like if whatever the container you have, like this container is of circular shape, or whether the container is of this shape, or whether it is like
Mhm.
this shape. Whatever the container is, whenever you pour liquid in it, The liquid will be in the bottom. The liquid will be in the bottom. The liquid will be in the
Yeah.
bottom. This is what they are asking. How you will justify according to the particles?
Oh, because the particles are like not that far from each other. It's like
Yes,
close to each
they
other.
are. They are
That's
not
why.
far. They actually, the in the liquid, the particles are randomly arranged, right? They are not. They have not a clear sequence. They don't have a regular
Yeah,
sequence, just like the
but
solid.
close.
They have irregular arrangement as well as they have some spaces
Yeah.
available, right? So whenever you pour that liquid in the container, so the
Yes.
particles, they will slide past each other. The particles will slide past each other. Slide past means they will pass each other and they will take the shape of the container. Whatever the container shape is, the liquid will take that particular shape. Just like the ice cubes. Whenever what is the shape of ice cubes? They are just like this. Why they are like this? Because when you fill the that pallet in which when you fill the water in that pallet for the ice and you place it in the refrigerator, what happens? After some time, after a few hours, you get the ice cubes of that particular shape. Why is it so? Because
Yes.
in the liquid, the particles have some spaces available, okay? And when you pour this liquid in the container, the particles they slide past each other. They slide past each other and then they take the shape of that particular container. Okay, I am repeating this again
Mhm.
that in the liquid, the particles are they are quite far apart from each other. They are not much far apart, just like the gases. You can say in the liquid, the particles have some spaces available, and they are they have
Oh,
random movement. Okay, they are not they are randomly arranged. So whenever you pour a liquid in the container, the particles in the liquid they slide past each other and they take the shape of the container. Okay, they slide past each other and they fill
container.
in the bottom of the container, and in this way they take the shape of the container. That's why they are in the bottom. Clear? They slide past each other and
Yes.
they take the shape of the container. Clear? Just
Yeah.
like I am telling you, I am expecting the same answers in the similar manner. I am expecting this answers in the similar manner in the test. Okay, so you must practice. You must have the writing practice, good writing practice, because the examiner will not see. How can he know that you have the clear concepts? Definitely, your paper will speak for you. So you must know how to write the answers. That's why I am repeating twice so that you may get idea of how to write the answer. Okay, and how to start and how to write. And you must know about the time management because sometimes we have in the short questions we don't have much time. We have less time, and we have to summarize our answer in 2 or 3 lines. Right? Have
Yeah.
you seen any past papers? Have you go through any of the past papers of any subject?
Uh, yes.
So you have seen, like if they have given you the question for 2 marks, so there will be 2 or 3 lines, maybe like this, and they have
Yeah.
mentioned like two over here. So you will just have that place, and you have to write your answer in that space, in that particular space. So it means you must be
Mhm.
concise in your answer. And how you will be concise? When you know how to write the answer. And this will,
Yeah.
when you will practice it, how you can practice? You can practice it by writing. Okay, solve the exercise which in your book, or you can solve the past paper and write the answer. Okay, and you can send me the answers. Then I will tell you whether that's okay or not. Clear?
Mhm. Yes.
Sorry,
Uh, my dad said he sent you a message on WhatsApp.
I can't. Wait a minute.